Hi, this is Dave. I'm here at day 2 at NEAF with Rick Hedrick of PlaneWave Instruments, who also doubles as Secretary of the Astronomy Foundation and my great colleague. Rick is going to tell us about what's happening at PlaneWave and some of the spectacular telescopes and imaging that they do. Rick, it's really good to see you today. Thanks for being with us.
Yeah, thank you. It's great to be here. This is a wonderful show. NEAF has always been a great show, and it just it seems like it's growing every year. And this has been a fabulous weekend. What I have over here is our CDK-24. This is an f6.8 CDK telescope. I've got, this is on our A200 German equatorial mount.
Mm-hmm. Fantastic.
And this is, I'll tell you a little bit about what else we have in the telescope. You know, right here I have an apogee camera on this one.
Mm-hmm.
I also have an FLI camera on one of our other telescopes.
Mm-hmm.
And I usually have an SPIC camera on some of the other telescopes too.
Yeah.
Right here I have our rotating focuser, which is a fairly new product.
Mm-hmm.
This focuser is used as a derotator for our Altaz telescopes, and it's used as a framing rotator for astrophotography if you need to find a guide star. And it's also a focuser. So it's a very heavy-duty focuser. It can actually, we can have 40 foot-pounds on this, so it holds a very large load. And it also, can lift more weight than it needs to. It can lift like 200 pounds.
These scopes are built like beautiful tanks.
A dainty tank. And then we have our A200 mount, and this mount is just really gaining momentum. We have several people buying multiple mounts once they've used one. And I'd like to show a couple of features here.
Yes.
Is if you come to this side,
yeah,
you can actually, I have the cover off here, and we can run cables through the mount. I can actually reach my hand up here, underneath the dovetail. There's a hole in the dovetail. And I can drop an extension cord down there, pull it out the bottom here, run it down through here, and then it drops out the bottom of the back of the RA base.
Fantastic.
And the idea is that you should be able to run whatever cables you want. You can't anticipate what people are going to do. You think you can, but you can't.
Right.
You always do something different.
Yeah.
So this allows them the freedom to do whatever they want. The other thing we have on this mount is we have integrated access encoders. These are high-resolution access encoders. There's one in the lower part here and the lower part here. They're like 10-inch disc encoders.
Wow.
What we use these to improve tracking. It gets rid of all periodic error and all the mechanical gear noise that there is in mounts. And it also, we use it for improving our mount modeling. So rather than having all the gear train errors show through when you're making a mount model, we have basically perfect measuring tools for telling the position of the mount. And sort of a result I can show you over here.
Sure.
This is just a quick example of unguided exposures taken with our mount. This is a 20-inch telescope, so the focal length is about 3,500 millimeters, and this is 15 300-second luminance and 8 R, G, and B 300 seconds. So these are several 5-minute exposures all stacked together, and the stars are perfect with less than like 5% elongation.
With the great field of course, the Whirlpool galaxy.
Yeah, it's a Whirlpool. This is 52 millimeters across, showing the performance of the CDK there, but also showing the performance of the mount. This is all unguided. So we can basically get about 95, 99%, something like that, of 5-minute unguided shots.
Fantastic.
And 10-minute unguided, we're shooting probably 60% of those, and we're constantly trying to improve this. And we've had several 15-minute unguided. We can do about 50%, 60% of those are good.
Spectacular.
But we're continually trying to improve that. But it's the other advantage to having something that tracks so smoothly is when you're guiding. you want to guide at much slower rates. You can take 10-second guide images and do updates, every 10 seconds. You don't really want to update fast because it tracks so smoothly.
Sure.
Start chasing the scene.
Sure.
So
yep.
It's an example there.
It's fantastic.
Have here our 12.5. This is an F8 system. And
this is in use by many astro imagers.
Yeah, this was, especially in the beginning 2 years of the company, this is the one that really started filling out our gallery. And if you go to PlaneWave.com and look at our gallery, I think we have one of the best galleries in the industry because we have such good astrophotographers.
Yes.
People are not only skilled at collecting data, they're artists at processing the data.
Exactly.
I'm quite good at collecting data. I'm not an artist at processing data. and then over here we have our 17. And this is another one that's really now gained a lot of momentum with the imagers. So now I'm starting to find that most of our best images are coming from 17s. Just because we've started, the sales of those have really started getting to imagers' hands.
Yeah.
I think originally they're 12.5s mostly by imagers. Now that the imagers have really taken on the 17. So it's this one here. And then we have over here, we sell a lot of telescopes with the Mathis mount, so we work very closely with Tom Mathis and Mathis Instruments. And this is the Mathis 1000 mount. And we have a 20-inch on it. Generally, we mount on this a 20 or 24, but for this show, we mounted. Tom made a couple of adapters so we could put the 20 on it.
Spectacular.
Yeah. So here we have, and here we're showing an FLI cable here, and the 20-inch is the one that's probably sold, to a lot of universities. We still have quite a few amateurs building their personal observatories buying this. So I guess the last thing I'd like to show you over here is just sort of the performance of the telescope. Let's see here. I'll just put this one up. Here's just an example, real quickly.
Pelican Nebula?
Yeah, and this is a 52 millimeter field. This is a 16803 chip. This one's taken with the 12.5 as it is. Here's a star in the center, and it's automatically moving. Star in the center, star at the edge, and it gives you perfect stars across the field. And then this is just another example of the same thing. This is a 17-inch, 52 millimeter field. Stars in the center, stars in the corner. And those perfect stars. And that's really kind of the whole point of the CDK.
Sure.
Was really to have these perfect stars across a big field.
Fantastic.
And that's kind of what we're doing here at NEAF. We do also have our CDK 700, a little bit big to bring to the show.
Right.
This is our Altaz, kind of observatory class. Telescope. It's $185,000. It has dual Naismith focus, so the focus can come out here, or you can rotate the tertiary and have the focus come out the other end.
Yeah.
And this telescope has direct drive motors and covers 70 millimeter field. It's directional limit across the whole field. And that's kind of what we're doing here at PlaneWave.
Well, fantastic. Thanks so much for spending this time with us, and I'm sure the readers will be very enthusiastic to learn everything they can about the instruments.
Well, great. Well, for those of you that didn't get to make it at NEAF, try to be here next year. It's a great show.
Thanks so much, Rick.
I even bought some.
Yeah.
Gentleman that sells these cases.
Oh, those are beautiful. Those are beautiful. Yeah.
So I've been doing this CCD imaging for a long time.
Yeah.
And now that we have a permanent observatory that we can log on to whenever we want, the next time I go observing and take a telescope out, it's going to be my dog. So I'm really excited to, my buddies and I go out and actually do the old-fashioned visual observing. It's been a while.
Nice.
So,
beautiful.
Thanks, everyone.
Thank you very much, Rick, for spending a little time with us.
All right, bye-bye.